This is Euclid Book 3, proposition number 14, and this may be one video and it may end up being two, so hang in there, folks. We're not really sure at this point. We do know we have a circle here. It starts at A, it comes up here to B, it goes over here to D, and it comes all the way back down to C. It's a very big circle. And within that circle you have two lines. They are equally the same size. We have AB here, and it is exactly the same length as CD. And that's all we know. What we're going to prove is that AB is the same distance from point E, which happens to be the center of the circle, as CD. And let's say that one more time. Line AB is the same distance from point E as line CD. That's what we're going to prove. Okay. Well, first of all, we have to find the center of the circle, because Euclid doesn't just give it to us. We have to find it for ourselves, and it ends up being point E because of Euclid Book 3, proposition number 1. Alright. Now, the next thing Euclid says is that because AB is the same size as CD, we're going to apply Euclid Book 3, proposition number 3 to draw a line from E to F and from E to G. And when you have a line EF and you have a line EG like this, if it's perpendicular to CD and to AB, which is something we covered in Book 3, proposition number 3, then we can also say that line CD and line AB were bisected by EF and EG. If you don't believe me, you can go back to Euclid Book 3, proposition number 3, and see for yourself. Okay. We have now established that AB was bisected by EF at point F, and that line CD was bisected by EG at point G. Now that means that the length of AF and the length of FB are exactly the same. And it also means that the length of CG and GD are exactly the same. Now, since AF is equal to FB in length, then we can say that the length of AB is twice the length of AF. We can then go on to say that the length of CD is twice the length of the line CG. So, if you were to take twice the length of AF, in other words, you took the length of AF, you multiplied it by 2, you'd have the length of AB. If you took the length of CG and you multiplied it by 2, you'd have the length of CD. Alright. Now, you're going to draw two more lines. One from point A to point E, another one from point C to point E. And guess what? AE and EC are equal in size because of all radii of a circle are equal. Now, if you'll go back to Euclid Book 1, proposition 47, and all the way straight through Book 2, we talked about squares of lines. Okay? So what we did was we had a line like this, AE, and it became one side of a four-sided square. Okay? So you'd have AE, and then you have three other lines that would be equal in length to AE, and it'd all be connected together to make a perfect square. Alright, so we've now established that AE and EC are equal in length because all radii of a circle are equal. Therefore, the square of AE and the square of CE are equal in size because AE and CE are equal in length. Okay. Okay. Alright, now we're going to go back to Euclid Book 1, proposition number 47. This is the Pythagorean theorem, in case you guys don't remember, and if you don't remember, you should go back. Anyway, we know that the square of AF plus the square of FE is if you were to add those two areas together, those square areas together, AF and FE, you would get the square of AE. So the area of AF, the area of FE, is equal to the area of AE. That's by Euclid Book 1, proposition number 47. The same is true if you were to add the area of CG and GE. Add these two areas, you get the area of CE. Boom. That means that the area of AF plus FE is equal in size to the area of CG plus GE. And if you were to remove the area of FE and GE, then you would have AF equaling CG. The areas of AF and CG are equal in size. Alright, and we've also established that if you remove the area of AF and CG from AF and FE plus CG plus GE, then the area of FE and GE are equal in size. And if these two areas are equal in size, then that means that the length of EF and EG are equal in size. And now, because of Euclid Book 3, definition number 4, we can now say that the line AB here is equal in distance from E as line CD. Alright, but Euclid's not done with his proof yet. And I'm going to tell you the rest of his proof in the next video, so stay tuned.